Hello everyone, today we are going over concepts 5-5 and 5-6, so gravitational potential energy and spring potential energy. So at first, as always, have your formula sheet right next to you, but also, just for your convenience, I've written out the relevant equations here today. So we have potential energy, which I've noted by PE, potential energy, is equal to the mass of an object times the gravitational acceleration times the height. So the mass of an object is often unchanging in most of these scenarios. The gravitational acceleration is the acceleration exerted by Earth's gravitational force, which is 9.81 meters per second squared, or just often rounded off to 10 meters per second squared. The height, which is the main determinant of the potential energy, can be changed readily. You can bring an object higher, or you can drop an object, changing that potential energy. The other equation we have here is the spring potential energy, which is denoted by U sub s. And U sub s is equal to 1/2 times the spring constant K times the change in the compression or extension of that spring. And what I want to also note is that it is the absolute value of that extension or compression. So the energy is not negative. If you have a negative delta x, let's say you compress that spring inward, the energy is not going to be negative. It'll be positive because of these absolute value markers. And further, let's denote the relationship between the energy and the extension or compression. It's if we increase the extension or compression by a factor of 2, because that extension or compression is squared, the energy will increase by a factor of 4. Whereas if we look at the just potential energy, not spring potential energy, we see a direct relationship between all these variables. And if you increase height by a factor of 2, potential energy will increase by a factor of 2. Mass by a factor of 2, potential energy by a factor of 2. So with that knowledge, that's just important to keep in mind for the relationship between these different variables and how affecting one would affect the other. So with that, let's just get started with these questions. So let's do 5-5, quiz question 1 and quiz question 2 all in one go. We have, when an object is near the Earth's surface, the gravitational potential energy depends on which of the following. So I'm going to rewrite the potential energy equation, mgh, and the answer choices are A, the speed of the object, B, the vertical height of the object above the ground, and C, the mass of the object. Well, just looking at this equation here, we can see in that equation, we can directly see that B is directly available in that equation and C is directly available in that equation. But we don't see A anywhere. And when we're considering the potential energy, whether it's in free fall, if it were like falling and you're measuring it at an instant, or if it's staying still on some surface, the potential energy is not dependent on the speed of the object. The speed of the object would help determine the kinetic energy, but the potential energy would not be affected by the speed of the object. So if it were rolling horizontally in the x direction, or if it was if it had a speed of 100 meters per second versus 10 meters per second, that would not affect it. That would not affect the potential energy. So A is false, but B and C are true because they are directly written within this equation. They are directly shown within this equation. So B and C are true, and that is denoted by the solution here as well. 5-5 question 2. Which of the following results in a larger change in gravitational potential energy? Taking an elevator up to the top floor of the building or taking the stairs up? So we have to recognize in this potential energy equation, I'm going to write it one last time. We have to recognize that as long as the height is the same, for two objects with the same mass, so if we have two bricks with the same mass, and they go up the same distance, let's say 1 meter each, they're going to have the same potential energy, because if we just write out qualitatively the equation, we have 10 kilograms times 10 meters per second squared times 1 meter. It's the same for both of these bricks. And regardless of the method it took to get to that height, as long as you're at that height, the potential energy is going to be the same. So we could say that this brick took a diagonal path, but as long as it ended up with a height of 1 meter, which is denoted in this question because it says the top floor of the same building, the potential energy will be the same overall. So the answer choice C is the best answer because we are considering the same person, which would have the same mass, presumably. We have the same effect of gravitational acceleration because we're on the same planet Earth, and the height ends up being the same because it's on the top floor of the same building. So that is why C is the answer. Either A or B is considering extraneous factors that do not relate to the question because the height at the end remains the same, meaning these two are false. And D is not true because we can determine it based on the information because we know the height and we know the mass of the person is unchanging. And we know that the height is the same. 5-6 quiz question 1 is simply an analysis of the spring potential energy equation. So as I had stated, spring potential energy, which is I'm denoting as SPE, but it was also noted as U sub S, is equal to 1/2 times the spring constant, K, times delta X, absolute valued, squared. So let's read our answer choices. Spring potential energy is proportional to the distance the spring is stretched or compressed, the square of the distance the spring is stretched or compressed, the length of the spring, the square of the length of the spring. So we don't have anything in this equation denoting the length of the spring. So that one's false. Both C and D are false. And between A and B, the square of the distance the spring is compressed, that's noting the squared value right here. So that's why B is the answer, because the distance the spring is stretched or compressed is squared in order to calculate the spring potential energy. And that is why A is false, because it does not consider the fact that the spring distance compressed or stretched is squared in order to calculate the spring potential energy of a specific spring. For 5-5B, we have 3 identical balls are thrown from a cliff with the same speed but different angles. Which ball has the greatest change in gravitational potential energy from beginning to end? So this question might throw you for a loop. You might say that ball C has eventually a higher height, which must mean that, it must have the greatest potential energy change. But recall that if we look at this answer question, the ball is given an initial velocity, meaning it has an initial kinetic energy. That means all 3 balls have an initial kinetic energy of some value. Recall the conservation of energy, saying that energy is neither created nor destroyed, just converted into different forms. Recall that kinetic energy can be converted into potential energy, meaning that if something is thrown with an initial velocity v, it has that kinetic energy, and when that velocity is gone, that energy was converted into potential energy. So the initial potential energy at some specific height plus the kinetic energy would equal the overall energy. So overall. So if we're considering the initial position versus the final position, the route that it takes to get there does not matter, because we are considering the change in the potential energy. We're not considering which one at a specific point had the greatest. We are just saying which one had the greatest change. And since we're considering from initial point A, or the initial point to the final point, the potential energy is the same for all 3 of these balls because they have the same height to begin with. So that is why D is the answer. And C is not the answer because the potential energy change is not greater because we have this this increase in height. For 5-5C, we have a falling apple is speeding up as it moves in the direction of the gravitational force. So it's experiencing free fall motion. Let's just draw out the force diagram for that apple. So it's experiencing only the weight force. So recall that the free fall is when an object is only experiencing its weight force as the predictor of its movement. And weight force is just equal to mass times gravitational acceleration. Which of the following statements could be true about the apple experiencing free fall motion? And then more than one can be correct. The work done by the gravitational force is positive. So when we're considering work, we have to consider that work is equal to the force times cos theta, so the angle of the force, times the direction of motion. So if an apple is experiencing free fall, it is going downward. It is the displacement is downward, and the force is also downward. So cos theta would be 0. Theta would be equal to 0, so cos theta would be equal to 1. So as long as the force and the displacement are in the same direction, the work done is positive. So answer A is correct and answer B is incorrect, because when we are considering this equation here, work equals force times cos theta times displacement, when both the force and the displacement are in the same direction, the work done by the gravitational force, so we're considering the gravitational force, the work done by the gravitational force is positive. So let's consider our next set of answer choices, C and D. The gravitational potential energy is increasing. So recall, potential energy equals mass times gravitational acceleration times height. The only factor that's relevant here, because the apple's mass is not changing and the gravitational acceleration is not changing, is the height. So in order to increase gravitational potential energy, the height must increase. So if an apple is falling, if it's falling down, this is the apple, it's falling downward, its height is decreasing, so height is going down, which must mean that the overall potential energy is decreasing, which means that C is false and D is true, because if height were to decrease, we could just plug in fake numbers, say 2 kilograms times 10 times a height of 10 meters versus 2 kilograms times 10 meters per second squared times 3 meters up in the air. So let's say like the ball is now down here. The overall gravitational potential energy in each of these two cases, so this would be 200 joules, and then this would be 60 joules. We see a decrease in the potential energy, meaning that C is false and D is true, and that is why potential energy decreases as height decreases, because of this direct relationship between height and potential energy. Okay, so the final question we have here is, a spring-loaded toy dart gun is used to shoot darts. When the dart compresses the spring 4 centimeters, the system has 2.5 joules of spring potential energy. How much spring potential energy does the system have if the dart compresses the spring 8 centimeters? So there are two ways of approaching this question. You can first solve for K in case 1, where 2.5 equals 1 over 2 times K times 4 squared, and then solve for K, and then plug it into a new equation with 8 as the distance, and then just solve for spring potential energy. So we'd say question mark is equal to 1 over 2 times the K constant times 8 squared, and then solve for spring potential energy. Or we can set up a proportionality, and this way is a lot easier, because we can see that the spring potential energy, so SPE, is proportional to x squared. So when x increases by a factor of 2, so x increases by a factor of 2, the spring potential energy increases by a factor of 4. So with this in mind, we know that 2.5 is proportional to a distance compressed of 4 centimeters. So 4 centimeters squared would be 16 centimeters squared. So 2.5 is proportional to 16 cm squared. And if we plug in the new information of 8 centimeters, we could say that question mark is proportional to 8 cm, and then parentheses squared. And then continuing this through, we have 64 centimeters squared. But we can separate this. We can say that this is simply just 4 times 16 centimeters squared. So we know that the spring potential energy when the at 4 centimeters is proportional. So the spring potential energy is 2.5 joules at 4 centimeters. And at 8 centimeters, it's 4 times the amount of spring potential energy is 4 times greater, meaning that this would have to be equal to 10 joules, because when the distance compressed increases by a factor of 2, the energy the spring potential energy increased by a factor of 4. And that is why E would be the answer. And you can look here and see that solving for K gets you the same answer. So you could just follow this work. A little hard maybe sometimes just because it's in Word document notation, which is not the easiest to follow. But simply put, if you understand this proportionality and that by increasing the distance compressed by a factor of 2, you increase the spring potential energy by a factor of 4, then you can just solve this question a lot faster because you don't need to do this work. It's simply eyeballing, oh, distance compressed increased by a factor of 2, spring potential energy increased by a factor of 4. And that is why E is the answer, and that is our last question. Hopefully you enjoyed this video. If you did, please consider giving it a like, and have a great day.